Hey everyone, and welcome to BarCode. In this video we will explore something fundamental in Java, the primitive data types. When you want to create any kind of data in Java, you have to tell the program what kind of data it is so it knows how much memory to use and what kind of operations you can perform on it. Now in Java, these are split in two main categories, primitive and non-primitive ones. This video will only focus on the primitive data types. The non-primitive ones are more complex and they deserve their own video. However, we will briefly touch on strings, but a more in-depth tutorial will come in a later video. Java has 8 primitive data types. For storing whole numbers, you can choose from byte, short, int, or long. If you want to store decimal numbers, you have float or double. For storing a single character, you have the char. And Boolean is there if you need to store a logical true or false value. Now, let's go through them one by one. The byte data type can store whole numbers between -128 to 127 and requires only 8 bits of memory. If you're absolutely certain that your values will stay within this range, you can use byte to save some memory, like storing somebody's shoe size. The short data type stores whole numbers within the range of roughly -30,000 to 30,000 and requires 16 bits of memory. So if you want to store somebody's height, you can do it in a short. The int data type is the most commonly used for storing whole numbers. It requires 32 bits of memory and can hold values between roughly -2 billion to 2 billion. So if you want to store a city's population, for instance, you can do it with an int. Just like this. The long data type is used when you need to store very large numbers. It requires 64 bits of memory and can store numbers between -9 quintillion to 9 quintillion. That is a 19-digit number. For example, people search on Google on average 8.5 billion times per day. So if you want to store that value, you're gonna need a long. Now you see an L at the end of the number. You don't always have to include the L. If the number would fit in a regular integer, you can leave it out, but if you go beyond that range, you need to tell the compiler explicitly that this is a long number. Now on to the two types that can hold decimal numbers. If you want to have it short and simple, here you go. If you don't need high precision and or memory is a concern, you can use float. If you want to do more precise calculations, you should use double. Float has a memory allocation of 32 bits, while double that size, 64. Both their ranges are infinite. And just like by the long data type, if you're using float, you can tell the compiler it's a float by adding an F at the end of the number, and in case of a double, a D. Just like this. But you should know neither of them are always 100% accurate. Being able to store an infinite range of values comes at the cost of precision, so in some cases rounding might occur. Just keep this in mind. If you don't want a more in-depth explanation just yet, feel free to skip forward to the char data type. Otherwise, I will give my best to make it as simple and understandable as I can. As I mentioned before, they both have an infinite range which comes at the cost of precision. Float has a precision of 7 digits, while double 15 to 17 digits. Let me show you an example. I will pass in the same large number into a float and a double variable that print them out to the console. As you see, by the mybig float only the first 7 digits are precise, the rest got rounded up to 9. And by the mybig double I got 17 digits precision, but the rest of the digits were lost due to rounding. Now this display format is called the scientific notation. The part before the e is called the mantissa, the number after the e is the exponent. That means you need to multiply your number by 10 to the power of the exponent. So if your exponent is positive, you move the decimal point to the right, if it is negative to the left. There is one more thing I would like to mention. Although the range is infinite, there is actually a maximum value you can effectively store in them. Numbers larger than that will be either rounded down to this number or up to infinity. And if you want to know what these values are, you can pass in the following constants in variables and print them out to the console. And there is also a minimum value as well, meaning the smallest number close to 0. Everything smaller than that will be either rounded up to this number or down to 0. And again, if you're curious, here they are. The next is the char type. You can use it to store a single character, just like this. Or instead of the actual value in quotation marks, you can also use its ASCII code if you prefer, like this. And if you print them out to the console, you can see that the values are the same. There is a link to an ASCII table in the description if you are curious. And finally, the last primitive data type is called the Boolean. It is used to store true or false values. It is commonly used in control flow and logic-based operations like game logic. If you want to declare a Boolean, you do it like this. Now, just a little side note, although a Boolean can only have the values of true or false, represented by the digits of 1 and 0, for which a single bit would be enough, it still gets some memory reservations of 8 bits. The reason for it has to do with memory alignment and something called word tearing, but this is way out of scope of this video. I just thought I would briefly mention it in case someone is wondering why the discrepancy between the size of what it needs and what it gets. Now a quick look at strings. Although string is not a primitive data type, it is widely used in Java. If you want to store more than one character, such as a name, a message, or any kind of text, you can use the string class, just like this. Since string is a class, it comes with many built-in methods. But it has so much to offer, it needs a video on its own. So if you're interested, make sure to check that one out next. And there you have it, the 8 primitive data types in Java and a sneak peek into the string class. If anything was unclear or you have any questions, please let me know in the comments. If you found this video helpful, don't forget to hit like and subscribe. See you in the next one.